Because this chapter is about the properties of solutions, it makes sense that we're going to spend some time and talk about the different measures of concentration that we could possibly see. Remember that the definitions are that a solute is dissolved in a solvent to create a solution. And this is one of the trickier parts about these measures of concentration is, are we talking about the solvent or talking about the solution? And those can change, so you need to pay attention to that. One of the other things I want to say is that these measures of concentration are all saying the same thing. They're all saying how much solute is inside of our solution, and really they're just different ways of saying the same thing. So the units might change, but the overall amount, the measure of concentration of my solute in solution, does not actually change. So these are all saying the same thing in a different way. The first unit of concentration we saw in the first semester of general chemistry is molarity, and by far this is the most common measure of concentration. And even though this is the most common one, we do see other measures of concentration in the lab, and also we're going to be using specific measures of concentrations for some of the calculations that we're going to do later on. So remember, molarity is equal to mole of solute divided by the volume of the solution. So this is one of the trickier parts here. Remember, this is the volume of the solution, not the solvent. And so that's kind of important. And the units on molarity are mole per liter or just molar. The next measure of concentration that we're going to see is called a mole fraction. And sometimes the mole fraction is represented by an X. And that's really just saying how many moles of solute do we have in the total number of moles, where the total number of moles is the moles of the solute plus the moles of the solvent. And really what this is saying is what percentage of the total number of moles are due to the solute. And in this case, so mole fraction is equal to mole solute divided by mole total, and this number is going to be unitless, and it should always be less than the number 1. The next unit is called molality, which is really commonly mistaken for molarity. They're two different things, although they're vaguely similar. Molality means mole of solute divided by the mass of the solvent in kilograms. The unit on molality is mole per kilogram, or molar. The next unit is called parts by mass, and that's really just the mass of the solute divided by the mass of the solution. And so in this case, the mass of the solution is going to be mass of the solute plus the mass of the solvent. And in this case, we're going to include a multiplication factor, and depending on the multiplication factor, we're going to get different parts per mass units. So the first one is called a mass percent, and really that's what that's saying is what percentage of the total mass is due to the mass of the solute. To get the mass percent, the multiplication factor that we're going to multiply by this piece is 100, and that will give us the mass percent. So doing the same division, if we use the multiplication factor of 10 to the 6, we get parts per million, or 10 to the 9th, we get parts per billion. All of these are unitless numbers, and it's important to note that the only times that we typically use part per million and part per billion is when the concentration is very, very small. The next unit, and the last one, is called percent by volume, and it's very similar to the percent by mass. And really that's saying of the total volume of the solution, what percent of that volume is due to the volume of the solute. So you take the volume of the solute, divide by the volume of the solution, multiply by 100. That'll give you the percent by volume of your solute. And here again, this is a unitless number. So now let's look at an example. And like I said before, all of these measures of concentration are saying the same thing. So I give you an example here. I've told you that I'm dissolving ethanol in water, and I give you a certain amount. So I'm putting 14 milliliters of ethanol into 1 liter of water. And I've gone ahead and done some of the conversions that we're going to need for this. So hopefully you already know how to go from milliliters to grams to moles and things like that. But in 14 milliliters of ethanol, there's 11 grams and 0.344 moles of ethanol. And in a 1 liter of water, there's 1,000 grams of water and 55.6 moles. So depending on which concentration we're looking at, we're going to be using different values. But notice in all of these calculations for concentration that we're going to be doing, we're going to be talking about the same solution of ethanol and water. So the molarity of the solution is mole of solute divided by volume of solution. So the mole of the solute, ethanol, that was given here, and now you need to come up with the volume of the solution. So theoretically, that should be the addition of the two volumes, the volume of the solute and the volume of the solvent. So of ethanol, our solute, we have 14 milliliters. Of water, we have 1 liter or 1,000 milliliters. We're going to add those two numbers together. And I'll tell you that this is kind of a rough estimate. And because we're talking about the volume of the solution, when you mix two things together, the volume can actually change. So we're just doing a calculation here, looking at the units of concentration. If I really wanted to truly find the molarity of this solution, I would mix these two liquids together and calculate very closely what the volume of the solution is. So the volume might change a little bit. So here we're just going to assume that the volume is not changing. So the total volume of this solution is the volume of the solute plus the volume of the solvent. And so here we get a molarity of 0.339. So with the mass percent, what we're looking at is the grams of the solute divided by grams total. So we had 11 grams of ethanol. We had 1,000 grams of water plus our 11 grams of ethanol. So remember, grams total is grams of the solute, water, 11 grams, plus the grams of the solute, which is 1 kilogram or 1,000 grams of water. So when I do the mass percent, I take 11 and divide it by 1,011. And because we're looking at the mass percent, my multiplication factor is 100. So I get a mass percent of 1.09%. So we do the same calculation for parts per million, so it's the same ratio here, but now my multiplication factor is times 10 to the 6. So we go ahead and do our division of 1,000 grams divided by 1,011 grams, and we multiply by 10 to the 6. Here we get a fairly large number. And so this is why we typically only use parts per million when the concentrations are very, very small. So one of the things I want to warn you guys about is that this particular calculation is very, very tricky and it's very easy to get it wrong. And what most people do is they do this division and then they multiply by 1 times 10 to the 6th. And that's not what we're doing. We're multiplying by 10 to the 6th. And that'll give you an answer that's off by a factor of 10. So be very, very careful when you do this. So what I do is I do the division, and then I say times, and then I go ahead and enter in 10 to the 6th, which is y to the x value. So I say 10, y to the x 6, and then I hit equals to get the answer out. So you might want to do this a few times to make sure that you know how to enter this calculation into your calculator and get the right answer out. So mole fraction is mole solute divided by mole total. Mole total is the moles of the solute plus the moles of the solvent. So here we have 0.344 moles of ethanol, our solute. The total number of moles is 0.344 plus 55.6. When we do that, we get a mole fraction of 0.00615. The next one is molality. Molality is mole of solute divided by the mass of the solvent. And remember, the mass of the solvent needs to be in kilograms. So molality is the moles of the solute, which is ethanol that we have. And the mass of the solvent, so remember, this is not the mass of the solution, it's the mass of the solvent, is 1 kilogram. So remember, the mass of the solvent needs to be in kilograms. With this, we get our solution is 0.344 molal. So the last one is percent by volume. With this, it's the volume of the solute, our ethanol, divided by the volume of the solution. So here, I'm going ahead and assuming that the volume of the solution is our 14 milliliters of ethanol plus 1,000 milliliters of water. So 14 divided by 1,014 times 100 gives me 1.4% ethanol.